Hey, this is going to be a quick video on how to change your standard 4-motor drive into a 6-motor drive in your code. To start, we're going to assume that you have a drivetrain configured in the Devices panel, following the typical steps where you choose the ports that it's using and set your build settings such as a gear ratio and the type of cartridge you're using. And what we're going to do is look at the code that is generated by this behind the scenes and look where we can find it and then make some changes to it to support the extra motor on each side. In one of these projects, most of the code you write goes in the autonomous function or in user control, or perhaps in pre-autonomous. But if you scroll to the very top, there's a line that starts with Pragma region VEXcode generated robot configuration. We'll see a plus sign here, and if we expand that, we'll actually see a lot of lines of code that were collapsed that represent the configuration for devices that we have set up over here in the panel on the side. So that includes, for example, the drivetrain that we just set up. You'll see we chose ports 1 and 2 for the left side, and we in fact see ports 1 and port 2 for left motors A and B, and 11, 12 on the right side, 11 and 12 on the right side. Similarly, we see ratio 6:1, and that reflects that we chose blue cartridges, which have a 6:1 gear ratio, and that's the third argument here, false and true. This represents whether the motors are flipped or not. So when you tell the motor to spin forward on your drivetrain, we want that to correspond to the forward direction of your robot. So typically on one side of your robot, all the motors will be false. On the other side, they will all be true. If we make changes on this side, such as changing the gear cartridge to green, which has 18:1, if we select done, we'll see, whoops, it recollapses, so we'll just open the panel again and scroll back down. We see now that the motors are all defined with 18:1 instead of 6:1. Similarly, if we flip the direction of the robot and say done, what was false on the left side and true on the right side will flip. We can see it's now true on the left side and false on the right side. So this is typically handled for us behind the scenes. We don't have to worry about this code. But in our case, if we have a 6-motor drivetrain, there's no way for us to add a third motor to each side through this panel over here. So we need to find a way to edit this code ourselves. You might think that you could add code here. But the problem is, anytime you save your project, this whole section in between this line and scrolling down a ways, end region, and this line, all of this gets regenerated based off of what you have configured over here. So we can't just make the changes right here. We need to do something a little bit different, which will simply be to copy the drivetrain, the lines for the drivetrain. And again, this is just the drivetrain. If we, for example, had another motor on port 9 for an arm, we'll see that configuration show up here after the drivetrain. But if we're not trying to change that, we're just trying to change the drivetrain code, so we're going to select the lines just that are concerning the drivetrain. So what I'm going to do is I'm going to copy those, and I'm going to scroll all the way down past this end region. And in fact, I'll go all the way down to just begin project code, and I'll paste those right here. And you might notice if we build, I haven't saved. If we build at this point, it will tell us that there's an error, and that's because we have redefined left motor A, left motor B, etc. So we can't have this here and in the auto-generated section, so we need to remove it from the auto-generated section, and we'll do that by deleting it from the devices panel. So I'll say delete, and now if we look in the expanded robot configuration section, the only thing that we have in robot configuration code is that other arm motor. There's no more drivetrain here. But what we do have is the code that we copied and pasted out of it. So everything else should work the same. For example, if you had autonomous code that said drivetrain.driveFor 10 inches, that should work just like it did before. We've just moved where the code is somewhere where we can make changes to it. So we'll collapse this panel and look at the changes that we'll want to make here. To add a motor to each side, what we'll do is we'll copy one of the existing ones, paste it, and we have to give it a distinct name, so I'll call this left motor C. We'll change the port to reflect what port it's in. We'll say this one's in port 3. And then we'll notice that the ratio is the same, 18:1, reflecting the green cartridges, and that the true-false flag for whether it's flipped is the same. Again, typically these will all be the same on one side of the robot and all the opposite on the other side of the robot. This could differ if your robot is built in such a way that 2 of your motors are attached to gears that don't spin in the same direction. For example, 2 adjacent gears won't spin in the same direction. They'll always spin in opposition to each other. So in that case, one of these would potentially need to be flipped. That's something that depends on the build of your robot. So after we create left motor C on the new port, we need to also add it to the left drive smart motor group. So we see left motor A and left motor B. We'll just add left motor C to the list, and now the left side is happy. We'll repeat the steps on the right side, create a right motor C, put in port 13, and add right motor C to the right drive smart motor group. All right, we can save, build to make sure everything still works, and that's all of the changes that we needed to make to our code to have our 6-motor drivetrain work much the same as the 4-motor drive. I would recommend to test this, that you pick your robot off the floor so the wheels aren't touching, and then test each of these ports one at a time. So unplug 2 of them, ports 2 and 3, and have only port 1 plugged in. And then test with your code writing, test the joystick to make sure that when you spin, when you push the joystick forward, the drivetrain spins in the direction, the left side of the drivetrain spins in the direction you expect it to. Then unplug port 1, plug in port 2, test the same thing again, and then repeat with port 3. What you can do here is, make sure that each motor does properly drive the drivetrain. If it doesn't spin at all, then maybe there's a port mismatch. If it spins, if one of them spins but in the wrong direction, that's an indication that you need to flip one of the true to a false or vice versa to match. Repeat the same process for the right side, and if everything looks good, it should be all good to go. That's it.